We're going to continue our study of the rational to the real to the complex. We're currently examining real solutions by looking at mastering factoring. For many of you, this may be a review topic because it's going to be a key underlying skill in everything going forward. We're going to take a little more time to review that. So turning to page 47, let's re-examine our factoring toolbox. We have GCF, or greatest common factors, special cases known as difference of squares and difference of cubes is what we're focusing on right now. There's, of course, also perfect squares, like x minus 3 squared, which is, of course, equal to x squared minus 6x plus 9, as we so usefully used last class. And of AM factoring, where the leading coefficient is 1, where you add to get the middle term and multiply to get the last term. Factoring by grouping. And of course, the heavy-duty guns, completing the square. So let's examine how to use these techniques in a couple of different cases. Zooming on in. Right here we have x9 minus 16x to the fourth. The assignment is to write this as the product of two factors. Now, noticing that 9 and 16 are both perfect squares, that right there might be the first tool to occur to you. And that would work very well. Are there other solutions? I invite you to consider. Looking at example 2, we again run down our list. The first thing we might notice is there are some GCFs. For example, that x squared. X squared times 4 times y to the fourth minus 25z squared. Now 4 and 25 are both perfect squares. 4 and y to the fourth and z to 6 are both perfect squares because they have even coefficients. So then we can again use that perfect square to factor and create, of course, these conjugates. And, these are just like kind of a little bit warm up. Let's get to some more serious stuff. Now, consider the quadratic polynomial expression, 9x to the third plus 12x minus 5. We can factor this expression by considering 3x as a single quantity as follows. That if we say right here, 9x squared plus 12x minus 5 is the same as 3x squared plus 4 times 3x minus 5. This right here is what I like to call the blah method, where if, as Jorge Polya, the great mathematician, says, if you ever have a problem that you don't want to deal with and it's too complicated, then turn it into an easier one with the same structure. And this is what we did right here by thinking about 9x squared as instead this blah of 3x squared, so that we can call blah, or u, plus u minus 5. This becomes a much simpler use problem, where it's like, what adds to 4 and multiplies to negative 5? Well, plus 5 and negative 1. We then can just bring back or open up the blah or substitute for u if we want to be all formal about it. And there's our factorization. This right here is a very powerful method. Think about that, especially as we begin to examine some of these problems that look extremely complicated but have some interesting factors in them. Suppose we want to factor, last problem, suppose we want to factor x to the third minus 8. Do you see anything interesting about this expression? Well, this is a perfect cube and this is a perfect cube, so it's actually a very familiar type of expression for us. We can, of course, use SOAP, same, opposite, always positive, where we'd say x to the third minus 8 is equal to x minus 3 times, let's see, that's the same, opposite would tell me that the next one is positive, 2x plus 4. And that's, of course, applying a difference of q's. Same, opposite, always positive. Always positive. We'll continue with the practice on this in class. I'll see you there. Wishing you a wonderful rest of your day.